Welcome back. So in this final installment of these videos on the hierarchical linear model, I want to talk about actually adding an explanation for the variation in intercepts and potentially also slopes. So we're going to add a level 2 predictor. It has to be a level 2 predictor because beta 0, beta 1 from the random coefficient model, they varied in C. They didn't vary in I, they varied in C. So the only thing that can account for those variances is a predictor that also is at the second level, the level where the only index remaining is C. Now we don't have to do anything to the level 1 model relative to the random coefficient model. What we do have to actually do is change the level 2 model. And if we believe, and we'll do that for now, that we have a predictor Z sub C, in this case the immigration, the percentage of immigrants in the country, that affects, and we assume that it affects both the slope and the intercept, then we can actually rewrite the intercept equation as beta 0 C equals gamma 0 0 plus gamma 0 1 ZC plus delta 0 C. So we now say so some of the variation in the intercept is due to this variable ZC, and then there is some unexplained bit that will enter delta 0 C. And we have a slope equation where we say that beta 1 C equal to gamma 1 0 plus gamma 1 1 ZC plus delta 1 C. So we say the ZC accounts for some of the variation in the slopes, but there is some unexplained portion potentially that is delta 1C. Now, wait and see what happens when we now substitute the level 2 model equations into the level 1 model. We get the next mixed model, and that is going to have the following structure. YIC equals gamma 0 0 plus gamma 0 1 ZC plus gamma 1 0 XIC plus gamma 1 1 ZC times XIC plus then this error term that we saw before, delta 0 C plus delta 1 C XIC plus epsilon IC. This term here, this ZC times XIC, that is what we know as the cross-level interaction. It's an interaction because it's a product of two variables. It's cross-level because X is an individual level attribute, whereas Z is a country level attribute. These cross-level interactions, they add so much potential to these hierarchical linear models because now we really can start mixing explanations and start understanding how regression regimes may differ and why they differ across different countries. Now, of course, we have to make an additional assumption here because now we have a new variable Z. And so we have the same assumptions from the random coefficient model we discussed in the previous video, but now we have also to make an assumption analogous to regression analysis that ZC is weakly exogenous. So let's see what happens if we do this now in an analysis. I'm creating here the interaction between pole F and IMI01, and then I'm going to expand my model. I'm going to say, okay, in this portion of the model, I now have not just political efficacy, but also immigration and also this cross-level interaction I just created. And I still have the possibility that the intercepts and the slopes for political efficacy vary across countries. So let's estimate that. So here is what we get. And it all seems to look very fine, not? We get some estimates for the intercept, for the effect of immigration, for political efficacy, for the cross-level interaction. We get random effects here They seem reasonable, but let's go to the bottom here. This here. This is what you need to pay attention to. We've talked in class of the problem that you sometimes have with maximum likelihood not converging. This is an instance where that happened. And what it means is that we should ignore these results because we don't know if these are the true maximum likelihood estimates. We really don't. So the model did not converge and we should not interpret the results. Now what we sometimes do when we get these problems is then simplify the model by saying, well, let's go back to a random intercept model, and of course that does converge. And if you look at that, you will notice though that the effect of immigration, just like Hoge et al. Argued, doesn't really do anything. And I mean, this cross-level interaction doesn't really do much of anything either when it comes to the effect of political efficacy. So the effect of efficacy is not greater or weaker as a consequence of having a lot of immigrants. We know that because the T statistic is not statistically significant here. This is well short of 1.96. And for immigration, it's also well short of what we would normally associate with political statistical significance.